p-type semiconductor, n-type semiconductor, and what we are going to do is that we are going to merge, combine p-type and n-type. So this is the p-type, this is the n-type. At the there is a junction. That is what they explain. This is a junction. In between, there will be a junction. Okay. So this is lightly doped. This is lightly doped. You can see very less number of ions. So the boron accepted electron and becomes negatively charged, and that is what negative symbol. And for phosphorus, that it gave, it donate that electron, excess electron, and become positively charged, and here it become negatively charged. Okay. Now heavily doped. Heavily doped means there will be more number of negative ions and holes in the p-type region, p region. And there will be more number of positive ions and electrons in the n-type region. Okay, here it electrons are the charge carriers, so it is referred to as cathode. Here holes are the charge carriers, here it is anode. You have to keep, this is the symbol. Anode, cathode. This is a symbol of a diode. This is a semiconductor diode. Now we are close to the laser. This still here it is the fundamentals of semiconductor. Okay. Now we are going to discuss about the how it can generate lasing action. Lasing action means twin photons has to be generated. That twin photons of similar characteristics, same properties. Okay, that is very important. So how that twin photons can be generated, and it can subsequently leads to lasing action and formation of laser. Okay, that we are going to discuss. Now there is no external source, so here it is heavily doped. Just we discussed it till what we discussed is heavily doped, more number of negative ions and holes in the p region, more number of positive ions. This positive symbol represents phosphorus, p plus. Okay, phosphorus gave that donated that extra electron and become positively charged ion, that is plus. Boron accepted, or aluminum accepted the negative one. One vacant position is there, and one electron it accepted, and it become ion and stabilized. Okay, that is that boron ion is there, negative. Okay, and these are the charge carriers, holes. Here it is electron. Now what we are going to do is that, see, same thing, different picture. Okay, so what will happen? There is a junction here. There is a, this is a junction. Okay, this is a junction. So there is a junction. So towards the electrons, this is the electrons attracted towards the holes. The electrons will get attracted towards the holes. Sorry, not this one. Electrons attracted towards the holes. Okay, electrons are attracted towards the holes. So that will happen because there will be a, because opposite holes and electrons, there will be a tendency to attract each other. So electrons are crossing the junction. Electrons are crossing the junction. This is the junction. Okay, this is the junction. Electrons are crossing the junction. So I will draw a blue color line on the junction. So electrons are closing. Electrons are crossing the junction, and recombination of electron hole will happen. Recombination occurs between the electron and hole. Electron and hole will combine together, and it will become one. Now, what will happen if they combine together? It will disappear. It will go because there is no separate electron hole. It's combined together, and so positive and negative and become neutral. Like that you can imagine. So positive and negative, that positive electrode is a negative and hole is a positive symbol. So both fused together and become neutralized. So nothing will be there. Only the ions will remain. Only ions will remain. See here, only negative ions, negative ions, negative ions, negative and negative ions, and negative ions. Here only positive ions, positive ions, positive ions, positive ions. This is phosphorus positive and boron negative ion. Okay, so this existence of positive and negative charge will lead to a potential. You can see. So there will be a small potential difference, and you can see that flow of current, or there will be an electric field from positive to negative. From positive to negative, there will be an electric field inside, that is shown outside. This is just symbolic representation. Okay, it is, there is no external potential what imparted, or we are not adding any electronic sorry external potential difference. This is the potential generated inside the generated across the junction within the diode. So normally, if you simply if you keep a p type semiconductor and sorry m type semiconductor together, this will happen. So this potential will be automatically generated inside, and that potential is of value 0.6 volts. If it is silicon, it is of 0.6 volt. Germanium, it will be different, or it will arsenic, gallium arsenide, it will be different. This is I am explaining the concept, the principle of semiconductor here, but we are using gallium arsenide actually for lacing action. This principle I am explaining with the help of silicon. Okay, for silicon it is 0.6 volt. Now you can see there is a potential difference generated, and now we have to think about the external source. The external source. Now external source means this is a junction potential. Okay, this is the potential. This is the potential. This here inside one potential is generated, and flow of current will be in that potential difference. Flow is happening from left to right, positive to negative. The flow is happening. So forward biased means, now we are talking about bias. We are explaining forward biased semiconductor, reverse biased semiconductor. Now for that forward and reverse biased semiconductors, we have to use external power supply. So forward biased means positive here, negative here, positive here. Okay, positive, negative. Positive means positive will be connected to the cathode, and this, what will happen, this will cause this will cause the electrons to flow in the direction. Okay, and this is the reverse biased where opposite way. So when the flow of current or a flow of electrons is in this direction, then in the direction as that of the uh, for potential electric potential field, then that is called forward biased. And if the flow of current or flow of electrons opposite is opposite to the uh, electric field, junction electric field, then it is called